Thank you, John. So I hope that everyone can see the PowerPoint. Today's agenda, we just did our introductions very quickly because we have a lot that we want to get to. And like I mentioned, today is really about getting to know R. What is R? Why we use R? What can you do with R? And a little bit of working with R as well too. And tomorrow we'll transition to working in R. And then once we get wrapped up, we might even take a break in between if we need it. For a couple minutes, and then we're gonna have lunch. So for those of you in person, for those of you that aren't in person, I'm sorry. I'll put a sandwich in the freezer for you. You can have it. You can have it next week maybe. But yeah, without further ado, I'm gonna introduce John, or have John come up to the stand right here, and he will start off our content for today, getting to know R.
Thanks, Dan. So I guess before we start, I guess I should introduce myself. So I'm John Santos. I usually go by Santos because there's another John in the department. I study public opinion and political behavior. I'm known as sort of one of the like big quant people in the department. But fun fact about me, I've also done a lot of qualitative research, interviews, and focus groups, and that was because I used to work in the market research industry. So, so I do qualitative as well, and I'm not one of those quantitative imperialists, so to speak. So, so that's a little bit about me, and I guess just by a show of hands, like how many people have some experience doing quantitative analysis? Okay, so everybody here, so that's good. How many people have used, and some people in the chat, excellent. How many people have used R before? Oh, great, great. So for those of you with R experience, I do apologize. The first part might seem a bit basic, but we kind of have to go through that just for, looks like a mix of some never and some. Okay, so the folks online, rudimentary knowledge, perfect. So this is good. We have a good dispersion of experience levels here. So the first part is very basic, and it's just getting to know R. So namely, what is R? Why do we use R? And then for those of you who haven't already installed it, we'll install R in RStudio and sort of take a look at what the interface looks like. So spoiler alert, this workshop isn't actually about R. And I say that because conceptually, the theme of this workshop is really about using statistical software and using a command line interface, or at least knowing what commands the buttons you press did, if you end up using Stata or SPSS or something else. And you can retain a record of them, right, to conduct your analysis. And this is because using commands, knowing which commands were used, is how we conduct good research in accordance with two key principles of science, which I'll say in just a minute here. So at Western, we just happen to use R. Most of us here think it's better than Stata. It doesn't do everything better than Stata, but we think most of it does. It does most things better than Stata, but a lot of the general things also apply to Stata as well. So what is R? R basically is a statistical package, right? It's a way that we analyze data. And if you've used Microsoft Excel, you've used a statistical package. In fact, a lot of the bread and butter techniques of social science analysis, t-tests, descriptive statistics, chi-square tests, up to multiple regression, OLS regression, and ANOVA, you can actually do in Microsoft Excel. We don't use Microsoft Excel because it would be really tedious, because we have to do everything through point and click, and we have to do a lot of organization of our outputs manually. And then any sort of diagnostic or post-estimation procedure, we would have to do manually through like vectorized column-wise operations. And so that's why we don't use Excel, but certainly for a lot of the bread and butter social science work, we actually could, right? So that's why dedicated specialized statistical software like SAS, SPSS, Stata was generated, right? And so the stuff on the right is Stata. And in Excel, we only ever see the data view. In Stata or SPSS, you have to sort of dig up the data view. And the screen that we work off is the top view, right? Which is the command line or the command line plus graphical user interface, right? Where we see our variables, we see the commands that we run, our output window, that sort of thing, right? And so R is very similar to those things with a few exceptions. First of all, R is free, right? It's open source. All of the packages that are developed to add on to it are also open source. The cheapest paid software is Stata, which for a student license, a perpetual license, is about $750, if I remember well, Canadian. That gets you a year of updates, and then no more. So I'm still using my Stata 15 that I purchased in my master's many years ago, and I haven't bothered updating it since then. Right? R is also different because there are no menus. So with SPSS or with Stata rather, you can see the command point and click interface there, which allows you to do things by commands, and then the output window shows you which commands you run. So in R, there's none of that, right? So you really do have to code everything, but that's not, don't be scared about having to code. R is also not self-contained, right? So in Stata, everything is sort of self-contained. There's minimal installation that you need to do of additional packages. R, you'll have to install quite a bit of additional packages from the get-go to do stuff, right? So things like the tidyverse, ggplot. But the plus side is all of those things are free. And there's an army of developers out there who are making and supporting and updating packages. Unlike Stata, where if a feature doesn't exist, you have to wait 1 year, 2 years for the next official release, and then drop another $700 to get that, right? So that's not cool. But really, the most powerful part of R is that it's an object-oriented software program, which means you can create multiple objects. In Stata, you can have precisely one data set open at any given time. Excel, again, I guess you could theoretically have multiple spreadsheets, but it's a bit of a pain. But yeah, with Stata, you can only have one data set active at a time. Your regression outputs are stored in this weird manner. It's difficult to retrieve them. If you want to create a custom table to present results, you have to save your data set, collapse it, do a bunch of weird output stuff. You don't have to do any of that stuff with R. You can make a million different objects and they will all be there ready for you to use. So it's really powerful in that way. And steps 2, 3, and 4 might seem like a hassle, but they pay dividends off in the long run. Now, as you can see, the R window here, it literally just is a command line interface. If you've used DOS or a Unix terminal, it looks just like that. And so very few people actually use the base program R. Most people use something called RStudio, which is an interactive development environment, which just makes things easier because you have different windows, and so you can see, like in window 1, you have your script file. So this would be like your stata do file or your SPS syntax file. 2 is the output console. This is basically the main view of R that you see there. 3 is your object list. So yeah, once you have like a project on the go, like this will be, three screens long, full of different objects that you've created. And then you have this plot window here, right? And so you can see this is sort of a toy example with the sample data set we're going to look at tomorrow. I opened up a data set. I viewed it. I ran this regression model predicting feeling thermometer ratings of Justin Trudeau. I printed out the regression summary output, and then I plotted the coefficients on this coefficient plot. And then I ran the plot again in order to put proper labels on things like that, right? So, at a very basic level, this is what your outputs in R will, or your inputs rather, will look like. And then these are examples of what the outputs look like. And, already you can start to see what the strengths of these things. in Excel, if you were to create a graph and you wanted to customize it, you have to point and click on every individual thing. And then if you want to duplicate that graph, you have to do every single one of those steps over and over again. Whereas with R, if I wanted to model the feeling thermometer ratings of all 5 party leaders, I could copy and paste this, change a couple of words, and it would be very easy to automatically generate everything again, right? And so this is sort of building up to why we use statistical software in general, but R in particular, is because the 2 principles of good science are transparency and reproducibility. If you're doing everything through point and click menus, nobody knows what the hell you've done. And in fact, if you return to your project in 3 months, you don't know what the hell you did. We were just literally having this conversation before the workshop started, right? So it just ensures that everybody knows what the hell happened with the data, right? And 2 is reproducibility. Not only do we know, but we can replicate the recipe of your data analysis, right? Because we have this folk understanding that science is this linear step-by-step process of getting data, analyzing data, presenting findings, when really, the analysis and presentation phase is iterative and takes multiple rounds. The first model you run will not be the model that you present, let alone the model that gets published, right? In between the getting the data and the publication phase, you're going to run diagnostic tests, you're going to test coefficients, you're going to run models with different variables, you're going to run models with different functional forms, you're going to test for interaction effects, and you're going to produce tables and figures for all of the above. And if you did all of that with a point and click interface, like it's very frustrating, right? So people get intimidated, so pay attention to you folks who haven't used R before to this next minute or so. It's like people get intimidated by the coding aspect of it. But because science is not this linear process, it's like this tangled, convoluted ball of string, coding everything actually makes things easier in the long run. And so, it means that not only other people, but also yourself can reproduce everything you did, which also makes it easy to diagnose errors, right? And so I'm going to stop talking in just a minute here, and we'll get to actually installing R, because there's more important things to spend our time on. I debated on what to call these functions. I sort of called it the complexity to hackery curve. And this is sort of my operating heuristic, is that R requires more effort to learn upfront, but this is an investment that pays dividends when you do more complex tasks, right? So anybody here know engineers? I'm married to an engineer, so engineers are always thinking up of systems, right? Because why do something one-off when we can design a system and it takes care of it for us, right? Engineers are stereotyped to be these very hard workers, right? But if you ask my wife, they're actually very lazy people. And it's because they, I'm obviously joking, but they're lazy in the sense that they don't ever want to repeat effort or be inefficient, right? Everything is about designing systems, right? Applied technologies in order to solve practical problems in a reliable, repeatable, accurate, consistent way, right? And so, doing stuff in Excel seems easy at first. But as the task gets more and more complex, the amount of hackery that you're going to have to engage in to get the task done will exponentially increase, right? You could imagine the y-axis as something more practical, more countable, like the number of F-bombs you'll drop as you're trying to get the software to do what you want it to do, right? So complexity on the x-axis, hackery or frustration or effort level required on the y-axis, and that's Microsoft Excel. And I've gone to the point now where I don't even use Excel for graphs if I can avoid it. I will make my graphs in R using ggplot and save them as images because it's easier that way. I can make 100 graphs in half an hour. In Excel, it'd be like 10 minutes per friggin' graph, right? Something like Stata or SPSS is also like it's a lot better than Excel, and I would say it's sort of a linear thing. Running linear models in Stata is actually quite easy, probably easier than R. But as soon as you get to running your diagnostics tests, conducting post-estimation, and then especially creating your graphics, Stata gets quite frustrating, actually, to the point where there are many quantitative-oriented, very well-respected scholars who, because they grew up with Stata, they still use Stata for most of their analysis. But when they create their presentation, like whether it's tables or visualizations, they send all of that stuff to R, and they use R to create their data visualizations, right? And when you see some of the things you can do with R, using ggplot, like mapping, like cartography, you can create interactive dashboards using Shiny. It integrates with presentation and PDFs. Like I wrote a paper that was entirely in R Markdown. So I did all of the analysis, and then I wrote the paper, and then I knitted it to PDF, and it looks like something you would receive at a conference, right? And that's where the complexity Hackery curve of R is this logarithmic function, right? So at the beginning, it might seem like you're doing, writing a lot of code to do something that would take 5 mouse clicks in Excel, or maybe 2 lines of code in Stata. But sort of as soon as you get the hang of it, you're going to find that it becomes much easier to do, something in like a very complex task in R versus, Excel or even Stata, right? So this is sort of the sales pitch for R. And in fact, I would posit that, there's some things like, running vote choice models on survey data was sort of the last bastion of Stata holdouts, right? And I would contend that there's this new package, R package called Survey Effects, and I would say it actually makes things a lot easier in R versus Stata. So that's it. I mean, we'll go to the good stuff here, but just any questions there? Any non-believers? Shania.
Well, I was just gonna say, so.
Or
for
additions.
people who are unfamiliar with any kind of quantitative models, it's probably gonna feel like a lot right now. Especially because you're throwing up the names of your columns and stuff, right? But the take home, I think, and you made this a great point, it's just that right now it's gonna feel very difficult learning the coding. If you've never worked in R, but the payoff is gonna be worth it, right? And that's what you're trying to convince us, and I think you've done a good job, but even if it feels like just looking at this is a lot, it'll make sense down the line as we keep going.
Yeah, Jesse.
Would we be using R or R Studio more often?
R Studio, yeah.
So, is there any use just R then? Just to use R Studio, or do we have to?
I have only ever used our studio, so don't ask me that.
I use R twice a year, and that's like literally like I'm not joking, like exactly like n equals 2 per year. Like at the beginning of every semester, I update my R version and all of my packages using base R instead of R Studio. I have scripts set up. I find it causes less problems for me. But otherwise, everything I do is in R Studio. Yeah. Did you guys have anything to add there? Or in general?
You don't
Yeah.
have any questions on that?
Yeah, no questions in the chat. So, okay. So that said, let me just ask, like, who already has R installed, or is there anyone that doesn't have R installed?
I never was able to open our studio.
Because the next few slides are literally just, oh, by the way, these graphs, okay, so we'll go through that here. These graphs, by the way, I did in R. If I did this in Stata, like I'd have to generate a variable, plot it. And in R, it's literally just one ggplot command. It's great. It's fantastic. Okay, so we'll go through installing R. I have instructions for Mac and PC users. If you're on Linux, I'm on Linux. I can help you, but let's maybe do that offline because no one needs to see that shit unnecessarily. Okay, so so first, as Jesse alluded to, R and RStudio are different. So let's install R first. So to do that, you can go to www.r-project.org. If your installation of R is more than a year old, now is a great time to update to the latest version. Because yeah, I can tell you that that awesome package survey effects will not work on versions of R before version 4. So if you want to use it. So once you're at r-project.org, click on CRAN. That simply means the Comprehensive R Archive Network, something like that. And yeah, we're going to download the funny looking kid version, 4.2.1. And then yeah, here are the instructions. If you're at a Mac, the screen looks like the left. Download the R-4.2.1 package, and then on Windows, it looks like the part on the right, and then download R-4.2.1 for Windows, and then save it somewhere and run the program. And then after you've done that and it's finished installing, let me know. So we'll give a couple of minutes for that. And then yeah, if you need, well, no one in this room needs help because they all have installed R already. So so while that's happening, what did the outlier say to the measure of central tendency? What did the outlier say to the measure of central tendency? Or centrality, if you prefer that term. Anyone in the chat know the answer? You're so mean.
Oh, man, that's a corny joke of the day.
I'll wait till you guys see my Halloween costume this year.
Oh, no.
Just testing if that's cool.
Let's just say it'll be quite a deviation from normal Halloween costumes. Oh, there's 2 of them in there. Sorry, that's my thing, is making stupid punny jokes. Okay, I'm gonna assume everyone's had it installed because if you don't, just somebody say something in the chat, and then we'll give another minute or so. Okay, seeing nothing in the chat, we'll now install RStudio. So go to rstudio.com and then click on the products menu like this, and then go to open source and click on RStudio, the premier IDE for R. And then scroll down and select install RStudio desktop. Select download RStudio desktop. The button's going to look like that. Select the open source license. Press the download button, and then obviously select the appropriate version, Mac or Windows. RStudio is less important to keep updated. Any installation within the last 2 years should be fine for anything that we're gonna do. If you're gonna start like developing your own packages and stuff like that, then you should install the latest one. But yeah, RStudio doesn't change nearly as frequently as R. But if you have like an old R version, like literally some packages will not work. Just because functions get deprecated and stuff like that. So you know, we'll give another minute for the folks who still have to install it.
So I have a copy of so haven't shared it with everyone yet
For the,
for today, the CES. So maybe on break.
I have it on a Google Drive.
Yeah, I saw that, but to share with everybody.
Everybody have RStudio installed? How are we doing, folks off in Zoom land? Sweet. Okay. I am going to assume unanimous consent to proceed. Seeing no objections, I will proceed. I spent some time as a professional moderator. Long story, not really, but ask me another time. Tips for working with R. So I'll leave you with these nuggets. Because again, we were literally joking about some of these things, the senior PhD students and some of the folks who were early. The first one is organize your projects in working directories. Like, you know, if you're a Windows user, like, don't keep everything in My Documents, right? My Documents is not Google Drive. Like make the friggin' folders to put stuff in, right? Because you know, as Dan will show you in a minute here, you know, one of the first steps we do is we set the working directory for the project because everything should be self-contained, right? You know, modern day data sets are getting pretty big now. So if you want to keep your data, your original data in a separate location, or maybe you want to keep it on the cloud, that's cool. But everything generated from the project should be self-contained within a folder. One project, one folder. If you do that, it will save headaches, right? Like when you do your methods one class, like make a folder in, you know, My Docs or your cloud drive or whatever called, you know, methods one course, right? And make a full separate folder for assignment 1, assignment 2, assignment 3, right? It's just, it'll make your life easier. To comment your code, like all it takes is a $ and like a quick little note to self, right? And don't just comment what you're doing, right? Comment why you're doing something, right? Like, because you're going to return back to the script and be like, oh, like, why did I run this Broich-Pagan test?
And commenting your code, like for people that are not familiar, it's basically like making notes to yourself, right?
Yeah.
So you're writing code that is executing something or doing something in R, and either below or above that, you're basically writing little notes for yourself about what you're doing.
Yeah. Like, well, I'll go to point number 3 first, right? And this is sort of in line with commenting, but use section headings in your scripts. This is one of the very powerful things about RStudio is that it recognizes not just section headings, but hierarchical section headings. So, you know, to go back to the example that I had here, you know, this is like a very simple routine, but I still put, you know, comments in the form of section headings, right? And yeah, so you make the section heading with a £, then your comment, and then a bunch of hyphens after that, right? If I did 2 pounds, that would be a level 2, right? So it would be a subsection of the first section. If I did 3 pounds, it would be subsection, right? If I did 4 pounds, it would be subsection. So it just makes your code a lot easier to follow. And then, RStudio has this outline view where you can literally click on a section and it will take you straight there, right? So you're not having to remember, like, oh, right, did it start at like line 967 or line 1222? Don't overwrite your original variables. Don't even use them in your analysis. Like, even if all you're doing, this might, if this other facilitators disagree with me, you can chirp in afterwards, right? But just don't, right? Like, just don't modify the original, because if some analysis comes back and you're like, why are like the People's Party way more supportive of increasing taxes than everybody else? It's like, if you overwrote the original variables, there's no way you can figure out that, oh, maybe I like reverse coded something, right? Or I forgot to reverse code something. So just don't, even if all you're doing is you're taking out like the missing codes, like which are usually 999 or 99 or 9, like just make a new variable, right? Just like, and then you can give it a nice name. Just don't overwrite the original variables. And on that note, like, give your variables like, substantively meaningful names that aren't very long. Like, try to avoid like unnecessary like hyphenation or length, because then it just becomes a pain to type things out, right? Like, you don't need to call the feeling _thermometer_rating_liberal, right? Call it FTlib. And then you can be like, oh, FTlib, FTcon, FTNDP, FTGRN, right? Just, it'll make your life easier. And then finally, back up your scripts. They take up hardly any space, so there's no excuse not to save everything. And save, we were talking about this too, save, script snippets, right? That you can repurpose later on, right? Like, if you wrote this really cool ggplot routine, save it so that, and keep a library of like, my R scripts, because you can always come back to it and play what I like to call it statistical Mad Libs, right? Where you take a script, you copy it, you paste it in your new thing, and you change all the variables and the scale units and all of that stuff, right? Like, it makes life a lot easier, right? Any other random tips from folks?
No, but I find you talked about do not overwrite your original variables. The naming of your variables, I mean, for me, as someone who just started learning R, I used to give names. My variables were names that are with you. So I just want to underscore John's point. Give them good, nice,
still
short,
do
normal
that.
names.
I still give them one. And I'm like, oh.
Yeah, as you get more advanced, like, there's some like tips and tricks that you can do, right? Like, you do your analysis and everything has compact but meaningful variable names. You can make like a tibble for presentation with longer names, because tibbles accommodate that easier than data frames, right? Talk to us when you get to that point and we can help with that. And then finally, like, when in doubt, Stack Overflow. Stack Overflow is a forum for programmers of all different languages, programming languages. I mean, different like world languages too, right? So if you think that the problem you're having is something original, like, no, you're wrong, right? You are Obi-Wan thinking that Camino doesn't exist, right? Like, no, you're wrong. It exists. You just haven't entered the right search term. Right? And yeah, I heard you can code without Stack Overflow. Bullshit. The other meme that I should have put here is the one from the Lion King of Simba, which is like, hotshot developer is Simba, and then the face of Rafiki has been replaced with the logo of Stack Overflow. Yes, it's like, yeah, no no programmer would be successful without Stack Overflow. Everyone goes to it, right? Even senior developers. So, and then obviously we are around to help too. But hopefully, the things you learn in this course will make the first few weeks of your methods course easier, and so that you're not trying to play catch up with dealing with the statistical software. So, why don't we take like a couple minutes bio break, and then we'll reconvene. Yeah, let's say I have 10:40 on the time here. Let's say like 10:43, and then we'll go on to dance stuff. And then yeah, if folks in the chat have any questions, I'm going to stick around here and answer your questions.
Yeah. Oh.
We can take a little bit of a longer break too. Got time.
Sorry, I was aiming for
Summary.
are you going to share your R script?
Yes.
Are they these like little
I'm gonna go between back and forth between. Yes, when not right away, but I will. I'm gonna go back and forth between sharing the
So,
screen.
like, are you gonna share the file with us?
Oh, the file with people.
Or were you just wanting people to pull it along?
What do you think? Yeah,
Library for open parentheses.
yeah. Okay, so I hope that everyone is back here in Zoom or Zoom land, as John calls it. So let's start to use R, shall we? Number one is creating a project. So in R, a project file stores your current RStudio working environment in a file within your file system. So this means that if you finish your work for the day, for the halfway through your analysis, you can open up your project file the next day and continue straight from where you left off. The other major benefit of creating projects is that a project file sets your defaults working directory. So this means that when you open a file, you only need to do so from the place of your project file. So yeah, basically RStudio, projects, it makes it straightforward to divide your work into multiple contexts, each with their own working directory, workspace, history, source documents, etc. So using RStudio project, it eliminates so much of the early stage hassle and confusion around reading in and exporting data. Setting up a working directory properly, also as John mentioned, it helps build up good habits that are really conducive and necessary for reproducible analyses later in the future. So RStudio projects, they are associated with our working directories. You can create an RStudio project in a brand new directory, in an existing directory where you already have our code and data, or even by cloning a version control from Git or Subversion repositories. So let's actually create a project. I have the instructions here on the slides. I would like to share my code perhaps, or I can run through it as well if you guys need me to. But step number one, we want somewhere on your computer is to make a folder where you want to save your work. So you can create a methods1 folder, you can create a gaps workshop in R folder for today, and also use it for tomorrow. So once you have that folder created, you are going to want to open up RStudio. Okay, so once your RStudio is open, I'll give you a second to make sure everyone is caught up. Now, in the upper right-hand corner in your RStudio, you're going to want to click the project button. So the buttons should say project none in brackets. Now, when you click that, sorry, the pictures, well, we're not really fitting nicely into the slides, everyone. But the first picture on the left at the bottom, you're going to see new directory, existing directory, or version control. So go ahead and click the existing directory. And then you're going to browse for the folder that you just created. So I'll stop sharing for a second and I'll show you my computer. Show screen.
Well, Dan's tapping with that. I'll just mention, not everyone uses the project system. And in fact, if you survey a group of R users, it's very, like, the opinions on whether or not we should use the project system are quite polarized. I don't, but I have nothing against it. It's sort of just half the tendency and inertia that people are using it, but it is a good way to organize things together and just sort of come up with other ways already. So you don't have to do this, but if you haven't tried it, give it a try and just to see if you like it and if it makes things easier.
So I just created, if everyone can follow my screen here, I just created a workshop folder on my desktop. I'm going to close this out. I'm going to open up our studio. Oh no, how can I share both?
We can see it on Zoom.
Yeah, but it's for people that are not. Have to update mine. Once again, for those on Zoom, I'll run it through you. Sorry if you're not if you're in person.
Could you disable like multiple
Yeah.
desktops, just so that there's only one desktop that we're all
Like a mirroring, yeah. Display settings. That to it? Nope. How is everyone in person? Like, you guys follow the instructions fine? Or yeah, okay. So this is just for those online, just for the edification. So yeah, so I opened up my RStudio in the corner. As you can see, new project. I click new project. It decides to open. Existing directory. I'm going to browse for the folder that I created before. Desktop, it's right here, workshop, open, and project is created. And there we are. Okay. So I'm going to stop sharing this for a moment. How do you get to new projects? Okay, so let me do it one more time, Carmen, for you online. So you open up your RStudio. So if you see in the right-hand corner here on RStudio, as you can see how this little drop down right here? Just let me know if you're following along, Carmen. Yep. And then you click new project. Just like that. And you can see this little screen popped up for me. You see that? New project wizard. Yes, okay. So you're going to click existing directory in the middle here. Now I created a folder before on my desktop called workshop. So I'm going to go browse. Just like that. Okay. And then I say that on my desktop. You got it. Okay, good. Open and then create project. Okay, beautiful. Good. Okay. Let me go back now. I'll go back to sharing the screen. Give me 1 second, everybody. And we're back. All right. So we've created our project. Now, John had mentioned before scripts. There's also our markdown files. How I was taught it in methods 1 is both. You see, using both scripts and markdown files. For today, I think it might be easier if we just worked with our markdown. it's up to you in terms of how, I'm not entirely sure of how Dr. Bree will have you guys working in methods 1 or how you might feel more comfortable working on in the future. But nevertheless, so once you're in your project, we're going to open up our markdown file here. Yes.
If I may, just for the folks who are new at this, the the R script is like a SPSS syntax file or a static view file, which just literally has all of the commands that you run. What the R markdown file is it has your commands and the outputs produced by the commands in the same document. So R markdown files are really good if you want to, output a Word document, a PDF document, or an HTML document.
Yes.
From the analyses that you're creating. So it's really good for generating like a finished one-page document. And we can pull up an example of this. That you want to send to somebody, that you want to send it to prof or for your comments or your friends for feedback. Whereas a script is literally just commands, right? So if you're just messing around trying to figure something out, sometimes a script is faster, but it doesn't save any of your outputs. Your R markdown file will save your outputs, and you can choose to sort of publish it to PDF or Word, HTML, or circulation. So that's really the big difference between the scripts, like a .r file versus a markdown file, which is a .rmv file.
Yes. And the art, like in the markdown, like John mentioned, the PDFs, HTML outputs, you ultimately, I'm sure that's what you're going to be doing in your classes anyway, to hand in assignments and such like that. So it's best that we'll run through that now. So opening your project.
Yeah, can you just repeat what I said? Because they couldn't really hear it.
Did. Okay, sure. Can you guys hear me? Yep. Okay. So John talked about the difference between R script and R markdown. So R markdown, this will allow you to have it'll give you an output of PDF for PDF, for HTML, for example, and in those cases you can also see your code, how it outputs, or the output of your code, and you can use that for handing in assignments or having your friends comments, for example. Whereas R script is just your basic is your R file. So those are really the two main differences between R markdown and just having a script. So once you guys are ready, we can open an R markdown file by clicking File at the top right corner of your computer. From there, you can click New File, and then you can click R markdown, and that will give you your R markdown file, and you can give it a name as well. And I'll run through that online for those of you who want to see it. There's so much open on my screen here, I can't. It's there.
We lost you on Zoom.
Lost me on Zoom? Yeah, that's because I'm just going to share my other screen. I lost the ability to, where is the screen sharing? Where did it go? Sorry, everyone, I lost my share screen little icon. I can't find it on my computer. It's lost because I'm screen sharing, or I'm screen mirroring rather. Where did it go? Here we go. I got it. No problem, guys. Yep, got it. Okay, just to run an R markdown really quickly, and then we'll move past this. Okay, so everyone can see, sorry for those of you in person here. Well, I guess I could try and do it like this. Yeah, there we go. So file. Top corner. New file, R Markdown. And then you can give it a nice little title, whatever you like, and you click OK, and then it'll give you your R Markdown file. I'm not going to create one because I have one open right now for us for today, but that's basically it. Okay, we shall move. Any questions with that in the chat? Everyone's good. Sorry, that took a little bit, that took a second of finagling. Okay. Let's open this back up. What I'll do is I'll give you the instructions first, and then I'll try to share share my code later on. Okay, so we created our project. We have our R Markdown file. So packages. This is what John was talking about before, and we're going to get into a little bit more detail now. So before I get into it, does anyone know what our packages are? An example of a package, maybe? Anyone in the chat or in person? Yeah, Jesse.
Our packages, so I think they give you different functions.
Yeah.
Yeah, let's say you want to make it that.
Good, great. That's one example. Yep. Anyone else want to add anything to that? Oh yeah, please in the chat. If you would, you could. If you would like to type it, or if you would like to, if you can say it out loud. If anyone in the chat. Yeah, tidyverse is a great example of one. We'll be talking about that more in depth tomorrow. Anyone else? Just about packages broadly speaking.
Survey effects.
Survey effects. I wonder who's plugging that. So our packages, what they are, they're collections of R functions. They're compiled code and sampled data. So in other words, just like Jesse mentioned, packages, they're these collections of add-on functions that enhance and expand the base R capabilities, or R's basic capabilities. So they are stored under a directory called a library in the R environments. And by default, R installs a set of packages during installation. I forget what exactly those ones are off by hand, but more packages are added later when they are needed for some specific purposes. So in the chat, Noah mentioned tidyverse. Jesse, he had mentioned graphing, for example. So ggplot comes to mind. So other packages which are already installed have to be loaded explicitly to be used by R, by the R program that is going to use them. So something to note, two things to note. Packages, one, they need to be downloaded and installed per major R version. Second, they are loaded in every R version before you need to use them. So an R session starts when you open the R program and when you either quit or reset. And an R session could last days or weeks. If you're not someone who quits your open apps and shuts down your computer every night, it could be as long as you want. Resetting R will unload all the packages that you've loaded. So how do we install packages? So there are two ways to add our packages. One is installing directly from the CRAN directory, which John had showed before. And another is downloading the package to your local system and installing it manually. So method one, downloading from CRAN, which is the Comprehensive Archive Network, is a collection of sites which carry identical material consisting of the R distributions, the contributed extensions, the documentation for R, and binaries. So I will show you an example of the code. How shall we do? So I'm going to stop the share once again of this. I'm going to go here. Screen share, our studio. I think that everyone can see my. Does it look funky?
On Zoom.
On Zoom, it looks funky. Yeah, let's try this.
Just try to stop sharing.
Yeah. Sorry, everybody. I have a few things running at once here. How about now? Is it because I have it, I'm mirroring it? Let's try it again like this. Sorry for those who are in person, you might not be able to see it. How about now?
Yeah, now we can see it.
Is it better now? Yeah. So what I'll do is I'll show those on the online first, and then I'll put it up for everybody. So for example, so the different ways of loading packages. So one is downloading from CRAN. So this command right here gets packages directly from the CRAN webpage and installs the packages in the R environment. So this is XML. I'm not going to run this right now because it's going to take a second, and I don't want to have to run through it again. Methods two is installing manually. So this is where you go to the link R packages to download the package needed. So you're going to save the package as a zip file in a suitable location in the local system, and you can run this command right here to install this package in the environment. I will share this in the chat with you guys. You can do this. I don't think you'll be using it as much, to get started with. The method 3 is the manual-ish way. So this is where, let's say, the package that you want to download. So let's say the Rio package, for example. So you go to packages in this bottom right-hand corner on your window in your directory. So you find packages right here. I click this. And you can see the system library. It shows all of the different packages that have been downloaded, but perhaps not installed. And I can go to install right here, just like this. And as you can see, we're going to install from the repository on CRAN. And let's say, for example, I want to find the package called Rio. So I click Rio just like this. And I'm going to install. This is updating loaded packages. So I click that. I'm going to show everyone in person as well too here. Let's try this actually. Does it look funky on Zoom?
Oh, that looks great.
It looks good?
Yeah.
Yeah, okay. So what I did was I installed the Rio package just like this. So I went to install. Well, it's loading for right now. Resuming my session. So again, installing from the repository. So all your packages, if you know it by name. So once again, I hit Rio. I click my Rio package and I install. And if you go here to the bottom right-hand corner, you can see all of your packages that have been downloaded. And I go to Rio. And as you can see right here, Rio has been downloaded. However, it hasn't been loaded or installed quite yet. Okay, so in terms of loading our packages, so before a package can be used in the code, we have to load it. So right now, it hasn't actually been loaded into our environments. So
Shared screen is frozen.
is it?
Yeah.
Okay, sorry guys. How about now?
No, it's good now.
Is it good now? It's because I have it on here. Okay, so I'll go back and forth. What we're going to have to do is we're going to have to load our packages using the following commands. So for those of you that are following online, as you can see right here, let's try the Rio package first. So what you're going to do is you're going to type in, you're going to create a new chunk. In creating a new chunk, you can do it in a few different ways. Number one, what you can do is you can click this little icon at the top. As you can see, it has like a C and a plus sign, and you click R, and it gives us a new chunk, just like this. So in your new chunk, you're going to type in library Rio. I'm going to get rid of these two right here. And what you can do is you can just click this run current chunk icon right here. We're good in the chat, yeah. So once I run that, as you can see in the bottom in your console, library Rio is run. And if you look in the bottom right-hand corner, you can see right here that Rio is downloaded and it's ready to go. It's been loaded into our environment. So let me just go to the people that are in person right here. All I did was I used this basic function right here, library bracket Rio. I run it. It's been loaded. And we have our Swiss Army knife for data Rio. Okay. So you can do this for anything. So I can go library. Let's say I want to do ggplot. Well, let's do tidyverse. Let's do tidyverse like this. And I can click the right chunk right here. And there we go.
You just have to.
Yeah, I'll run it again for those on Zoom. So I'm gonna come back here. Everyone on Zoom can see me. I'm good. So what I did was library.
But they'll have to install tidyverse.
Yeah, so you'll have to install tidyverse. So you can go, let's do it together. So library. Let's go back actually one. So at the bottom corner, you can click install. So you're gonna type tidy V, and this comes up, tidyverse. And you click install. Mine is gonna have to update.
Yeah, well, that's doing that.
Yeah.
Can I,
Sure, please.
um, So the tidyverse isn't actually a package. The tidyverse is a collection of packages.
Yes.
And so when you write tidyverse, it assumes that you mean dplyr, tidyr, per, map, bunch of
Yes,
other things.
right.
So yeah, so it's it might tell you to upload like or update dplyr, for example. Dplyr is just part of the tidyverse. So if you're wondering, like, oh, I keep installing tidyverse or loading tidyverse with the library tidyverse command, like whatever was this dplyr tidyr nonsense. It's just they're part of the tidyverse.
Right.
Can you just show them maybe an example of what it would look like if you try to load a package that you had installed?
Yeah, for sure.
Just so people
Yep,
can get a sense of,
100%.
like, how we
Yep.
know when things have.
Yeah. So let's say ggplot. Let me make sure I don't have it installed.
Yeah, that's okay. Or just like.
Let's do a random one.
Just do a bind. 'cause you
Yeah.
have that installed.
Yeah, abind. So let's do abind. Oh, I have that one
Oh, no,
installed.
never mind.
Let's do, I don't know, give me a random one.
Um.
Oh, tidy models.
Tidy models. Okay, so tidy.
So it's not coming up in there because. it's not on it,
So I'm gonna try and do it. And as you can see, there is no package called tidy models. And I'm gonna show everyone on the screen here. There's no such thing called tidy models. So once again, what do? I go to install. I find tidy models. I hit install. I'm just gonna say that for now. It's running.
Yeah, so this is something that.
Yes.
Do, right?
So it'll ask, as you can see at the bottom of the screen, do you want to install from sources the packages which need compilation? Yes, no, cancel. I'll show everyone on the screen here as well too. Can you guys see that at the bottom right corner right there? Yeah, right here in the console. So what I'll do here is hit yes. We can hit no or cancel.
So we type US.
Yeah, and it's running it.
You just.
Yep. And it might take a while.
If you ever have problems updating packages and it says package conflict, you want to restart. Like, one thing you can do is you can just start a new session of RStudio, or actually this is another thing that I sometimes use more for. Install the packages that need to be updated, close it down, and then install the new package that you're doing. Like a lot of users turning it off and then back on again, is a time-tested solution.
Let's go back to this now. Back to our slideshow. Okay. So you can find the documentation information for all the packages when you click the name in the packages dropdown as well. I can show you once I come out of this on my screen here. There are thousands of helpful R packages for you to use, but navigating them all can be a bit of a challenge. I'll talk about some of them here right now, but Shanae and Alvaro will give you more detail and talk about them more tomorrow. So the real package that I just loaded before. So the real package, it's a relatively recent R package, and it makes data import and export in R a little bit more painless and quicker. So the objective is mainly reached when Rio makes assumptions about the file format. So this means that Rio, really what it does is it guesses the format of the file you're trying to import. So like an Excel file or you name it. And then it applies this import function appropriate to that format. And so all of this is done behind the scenes and the user is just required to run the import function and our life is easy. So that's an import export function package. For example, we talked about tidyverse, so packages that manipulate data. So tidyverse, it's a collection, it's an opinionated collection of our packages. It's designed for data science. So all packages share an underlying design philosophy, grammar, and data structure, and the core packages that have functionality to model, transform, and visualize data like ggplot, dplyr, tibble, etc. And so packages that visualize data, a really nice one is ggplot. So that's R's famous package for making beautiful graphics. ggplot2 lets you use the grammar of graphics to build, layer, and customize plots. We won't be using it today. So we've created a project. We can install and download packages. Now we can have a little bit more fun in practicing and importing some data. So data can be read in from other data formats. So you can have stats, SPSS, Excel workbook, CSV, etc. Now to do this, we are going to use Rio. So we need the Rio package. So everyone's installed the Rio package, decent, fine, we're okay. Yeah, how about online? Has everyone installed the Rio package? I have some more detailed instructions of how you can download it here that you can follow rather than just have me mumble about it or show my screen. We're good? Yeah, everyone seems to be fine online as well too. Okay. So we've installed it, great. So we are going to be using CES data for today and tomorrow, the Canadian election study. Now we've manipulated a little bit. We're not going to be using the entire data set. There are, yeah, thanks, John. Yeah, you can run it that way as well too. We're not going to be using every single variable that's in it. We're going to be using a customized version of it. So I believe that John shared it before with everyone. Have you shared the data with everyone? If you want to, maybe you want to just talk about it for a second, John. Yep.
So the link up there that I wrote, bit.ly/CES for GAPS 2022. That's just the short form of the link so that you don't have to copy the alphabet soup after the link, and that will link to a public CSV file where you can download the data set. And it's something which this is increasingly becoming the norm, where your data is stored online. And that way, instead of having to keep it updated in different places, you can simply load it from any So you can literally tell R to open a data file from the internet, and it will do it without you don't do this for big data files, save them locally first, but this CSV file, I think is like 10 kilobytes or something small.
Yeah, I'm gonna let everybody have a second to find it. I'm sorry, what this data file?
No, let's see.
Oh, where to find it, where to find it. So if you want to follow this link right here,
Oh, yeah, Dan
Yeah.
will input the command in a second here, but
Yeah.
if you were to open your browser. and
I'm gonna-
use
yeah,
this data
we're not-
file,
yeah, we're
you'll
not
just
quite-
download the CSV.
yeah, we're not quite there yet. Just gonna wait for everyone online. John, I think we might have to do a sub. So everybody, I'm coming off of being sick and I'm still haven't recovered my voice completely yet, as you can maybe hear. So I might have John come in and sub in for me for a second or hour if anyone else would like to. With my deepest apologies.
Yeah, it's bit.ly/CES2022.
Yeah, it's in the chat.
Oh, it's.
So I have everything ready to go.
Okay.
Let me I'm just gonna grab a halls really quick.
Yeah.
Thanks.
This is gonna kill someone sometime. Okay. Okay. Okay, so I'll show you guys. Let me just see if I can get synchronized desktops here, because this is
Oh, here. This,
Yeah, I got the
not maps downloading. So when the data downloads, you want them to save it in that same folder that they've set up as their work.
Yep.
directory, right? Yeah, so just move it to whatever folder you kind of set up.
Yeah.
for the-
okay. Look at that. We have screen mirroring going on. Okay, so the link that I just sent you, if you were to, let me just open up a Firefox session here. There we go. CES for GAPS 2022. So you have a couple of options here as soon as this thing downloads. So yeah, so we could open it with Microsoft Excel, right? But what I'm going to do is I'm going to save this to the desktop. Or save it rather to Dan's working directory, which it did not save. Okay, so that's a bit inconvenient. So usually what we would do here is we would save the file to our working directory, and that would, let me just see if I can do this again here.
Save. What if you just open it? Oh, okay, yeah, now go over here.
Okay, we'll do this the manual way and then save it. Yeah. So another pro tip, go to your browser settings and under file download options, choose always ask to save, like always ask to specify a file location to save your stuff so that you're not having to go to your downloads folder and move things around. So yeah, like I'm trying to save here and
Go to sort file. at the top.
where's, like I'm pressing the save icon and it's not.
Yeah.
Oh, save as, yeah.
Save as, this is just a Mac thing.
Got ya. So I know it's under his user folder or under desktop. And then workshop. And yeah, we'll call it CES for intro to R. Do I need to add CSV or will it do it automatically? Yeah. Okay, so it's saved there. And now if we want to import it, you know, I'm going to call this data set CES. And so we're sort of already getting a first taste of some R commands, right? So the first thing we're going to do here is we're going to learn about the assignment command, right? So what I'm going to do is I'm going to make an object called CES, and then I'm going to tell R to find the data file we just downloaded, and we're going to assign it to this thing called CES that we're going to create, right? And the assignment operator is simply the left triangular bracket followed by a hyphen. So that's the assignment operator. It's sort of like the equals, but more encompassing than equals. And then we're gonna write our command, which is called read.csv. So that's the command that we're gonna run. And
There's a question on Zoom.
Yep. It's the folder, the folder that we created. Yeah. The R project, I believe, should be in that file. I'm kind of the wrong person to ask that question because I don't use projects.
Yeah, me neither.
Anyway.
The project will be this inside the folder.
Okay.
So Dan sort of covered this intuitively, but this is the structure of an R command. Read.csv is an R command. Now, if I were to type read.csv in the console, you know, it's going to tell us, oh, this is what the command does, right? Which isn't very useful to us. So what we actually need to do is we need to add an open and close parentheses after that. And then we can write what we want the command to read, right? And so in this case, we're going to read this file called CES underscore for gaps underscore 2022.csv. Now, if I were to run this, it says, whoa, we can't actually read that. And this is because whenever we have something like a word written down in R, it assumes that it's either an object or a command. And if it's not a command, then it must be an object. So, you know, this CES for gaps 2022.csv, it's not a command because no R programmer would have programmed that in. And it's also not an object because we haven't created anything like that, right? So we actually want to say that, oh, that's the name of the file, which means we need to enclose it in quotation marks. So what I'm going to do is I'm going to write the same command again, read.csv, and I'm going to go within parentheses. I'm going to type in double quotes, and I'm going to type the file name again, CES underscore for underscore gaps underscore 2022.csv. and it's not found. That's weird. Did I give it the right name?
No, I think the working directory is not set to the right.
Oh, sorry, CES for intro to R, sorry. Intro to R. There we go. So that command worked. Now, I'm writing stuff in the command console, and I'll explain why in a second here. This is just a place where you can test commands if you don't necessarily want to, save it. So you can do it in the console, or you can do it in the script window. So if I were to do this in the script window, oh shoot. What did I do, Dan? Undo it.
Command Z.
Holy shit. Nope. Okay. Just type in a 9 CSV. So CES _4 intro _2 R dot CSV. And if we run this, so you see it reads it. Don't worry about the commands I'm running right now. Yeah, don't do what I'm doing. Okay, so I ran this command read cs.csv and then in brackets, in quotation marks, CES _4 intro _2 R.csv. And it printed stuff out, which isn't particularly useful for us, right? What we actually want to do is we want to save it in our R environment so that we can do stuff with it, right? And so this means we need to assign this command to an object, right? So we're going to create an object called CES. And then we're going to use the assignment operator, which is the left triangular bracket and a hyphen. And then you add a space there. And so what this is saying is we're going to run the command read.csv. And the argument for that command is to find this file, CES for intro to R. And then we're going to take that and assign it to an object called CES. And so if I go run, we have now, it runs the command and it assigns it to this object called CES.
I was just gonna say, to take a step back, can you just explain again how the computer how R knows where that file is?
Yeah. So how does R know where the file is? Does anyone know? So this is why we create a working directory. We saved the file, we downloaded it, and we saved it to the working directory, which there we go. So which is in, yeah, I'm not going to be able to navigate it. But trust me when I say that it's on Dan's working directory folder that he created called workshop, right? So he created the folder, he created the R markdown file in which we are working, and he associated it with that folder, which means as long as we save that file with that file name in that folder, R knows where to find it. If you don't set a working directory, or if you don't create a project and save stuff in that working directory, R is not going to know where you saved it, right? And then you're going to have to write down a custom path to tell R where to find it, which isn't a problem. It's just, it's another step that you have to do in your analysis. So did I miss anything there, Chanel?
No, I was just gonna say, because sometimes that's not intuitive, right? It's like, how does the computer sort of know where this file is? We have tons of files on our computer, right? So if we had not saved that CES file into that folder that we're working out of, it wouldn't have been able to load it.
Yeah, and so, if you wanted to open up something outside of the working directory, for Windows users, you would probably have to do something like C colon slash users slash mine would be John slash documents slash so forth and so on. So you'd have to specify the full file path for that. Now, the reason I gave you that link, the bit.ly link there, is we can actually, so I'm gonna get rid of the CES object we just created, which is a very simple command. It's just rm and then in brackets the name of the object. We can actually load files directly from the internet, right? So I'm going to run the same command with www.bit.ly/CES for GAPS 2022. And if I run this, oh, cannot open the connection. It's just weird. Okay, well, this was working on my machine. So anyway, so this is why you download things, right? So okay. So does sort of that make sense? Like the structure of a command, right? We have the command and then in parentheses, the arguments associated with the command, right? And every command has different ways of declaring the arguments. So if you ever get stuck on something, the help is really easy to access. You just type in question mark. So I'll type this in the console, question mark, read.csv. And then if you run that command, it takes you to the page explaining what it is that you're doing, right? And how to do it, right? So you get this handy help file. There's the command that we're doing, a description, and then how you use it, right? So here are all the different arguments that are associated with it, right? So when we write the command read.csv with the name of the file in quotation marks, that's actually the argument file. It's sort of just like R just assumes that's what you mean, right? So this is an abbreviated statement, where this is, so this is actually the thing. Like for those of you who speak French, like you would like speaking informally, like you don't say like, you can, like when you're saying the negation, right? Like you'll often just say, pas instead of like ne pas, right? Yeah, that's sort of the closest analog that I have to it.
And like in this looks like a lot, right, on this help screen, because if you look at the read.csv, which is the specific function we're using, there's all these other potential arguments we could add to make it do other things, right? But just in this example, we're just using that file argument, and like John specified it up there.
Yeah, so like if there's no header row, you would go header equals false. There's an argument called skip equals. So if you download something from Statistics Canada, you're going to get a bunch of intro rows at the top, which you can't import. Or if you try to import them, it'll mess up your data file, right? So you would skip however many, introductory rows there are explaining the data set. So you might, go import census 2016 skip equals 10. And then you only get the actual meat and potatoes that you want to run. So that's that sort of commands in a nutshell and arguments. And then, yeah, oftentimes you're assigning things to objects because you want to save them and you want to work with them, right? Sometimes you're just, you're just running a command and you don't want to assign it to anything, but that's very rare. Almost all the time you're going to be assigning stuff to an object. Otherwise, R is not going to save it, right? Though this is, when you see the stuff tomorrow, if you're trying to figure out the, like if you're creating like a complex dplyr pipeline, sometimes you won't assign it to an object because you just want to sort of see how it works. And then you'll actually assign it to something when you know that it's not going to return an error. And this is also useful, like, if you're going to do like a data transformation, like, and you're unsure of it, like you can create a new object called CES_backup, right? And you can assign the old CES file to, your old CES object to this new object called CES backup. And it's sort of a convenient way if you, want to create just like a working backup in case you mess something up in the analysis. So that's another handy use of that. And then just while we're here, just sort of another thing that was implicit in what Dan was talking about. These commands are analogous to like a sequence of mouse clicks that you would do in any other software program, right? So if you can sort of like, if you've ever programmed a macro in a Microsoft program by using like the record macro button, where you click a bunch of things and then you press stop recording and then you run the macro and then the program runs with all of the mouse clicks that you did. None of these things are actually actualized until you run the command, right? And so you can run the command by selecting it and going run selected lines. You can run it by, typing something in the console, backup CES, and then pressing enter. You can also select a line and go control or command. Is it command enter on a Mac? Command enter, or on Windows, it's control R, I believe. To run a line, it's control R after you select, yeah. So one of those things where it's muscle memory to me, so I can't even remember it, so.
And that's like once you start working more on our, probably be running on the code.
Rather than hitting that one chunk.
Okay, cool.
Yeah.
Whenever you want to take over
You know
now.
what, I want to keep going on. I can't predict at all. But maybe really we're going to leave off with importing, just looking at the
Right. So, okay, so we've imported, the other thing I should say is the console window can get cluttered. If you ever want to just purge the output, there's the little broom icon in the corner. If you do that, it erases all of the output. Similarly, like if I were to write a command here, let's say, head CES, and if I ran that, it generates an output display here, which is quite nice because it's nicely formatted. If I want to hide that temporarily, I can hit the up arrow there and it collapses it. It collapses the output chunk. If I want to like delete this output, I can do that, right? Like, let's say I didn't want the head, I wanted like, the full data set. So I could run that. And now we can see that it's displaying more rows, which maybe you don't want, right? So you can close that and do that sort of thing. So we'll make a new chunk here. Let's see if this works on Mac. It does. Okay, so on Windows, you can do Control-Alt-I. On a Mac, you can do Command-Option-I, and it will insert a new chunk for you. So we want to actually look at this thing. If you type in the name of an object in in R, R assumes the command you are running with that object is to print. So if I just type in the name of an object, CES, and run that, it prints out all of the rows of this data set that we have, right? This is actually the same thing as me writing print, and then in parentheses, the name of the object, and we see that it's printing it. Oh, I see a question. I see
think
things.
Yeah, we've answered
Okay.
it.
There's just, missing the dot CSV.
This is also a good, shoot, no, that's not what I meant to do. Oh my goodness. Okay. There. Okay. So that's print CS. Now, this is a good sort of opportunity to point out that R is, if you're coming from SPSS, you'll know that there's no such thing as case sensitivity in SPSS. In R and Stata, case matters, right? So if I were to type in CES in all caps, R would say, I can't print this all caps CES. There's no such thing as an object called all caps CES, right? So just be mindful of that, right? Cases matters. You can use it to your advantage, right? Like, so, one convention that I sort of do is sometimes I name my models like uppercase. And then it's a way to have duplicate objects that are still differentiated, right? Or duplicate names, but differentiated objects. So just be mindful of that. You can also separate words with like underscores. Underscore is a legal name or a legal character for an object name in R. So is period. But you can't use hyphen because R thinks hyphens are the minus sign. Also, you usually cannot begin object names or row names with a number. So if I wanted to, let's say, call this, be more precise, call this the 21 CES, and I try and assign the CES object to that, it's going to say unexpected symbol in 2021 CES, right? Because you can't begin a name with a number, right? But if I wanted to call it CES 2021, that's totally legitimate. And you'll see that it created this object, CES or CES 2021. So that's just another thing to be mindful of. Okay. So if we want to sort of get the usual spreadsheet view that we're used to seeing, like in Microsoft Excel, the command is view with an uppercase V, CES. And that opens up another window where we can get a peek at the data set. And then, yeah, you can see different characteristics of the data set. Like we could scroll through here and eventually find out that, oh, there are 793 rows in the data set, right? And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 variables, right? Or you can look in the object window and see that we have 793 observations of 13 variables, right? So observations always go in the rows, the variables always go in the columns. Oh, some new messages there. Okay. Oh dear. Okay. And then, yeah, if we want to close this window, we can just close that. The lowercase view doesn't work. Don't ask me why, I don't know. Another useful command if you want to take a peek at data is head, it just shows you the first 6 rows. So if I were to write head, CES, it shows me the head of the data set. Similarly, we could do,
Delegate, what was-
oh, are you, okay, perfect, yeah. So yeah, so that's just, you know, if we're looking at the data, so. Oh, oh, what else do we have, Dan?
Basically, where we're getting at, we're gonna look at the data a little bit.
You don't want, surely we're not gonna run all this.
No, that was for my, that was my.
Okay.
If they want.
Oh, yeah, so yeah, another way, if you want to just look at the data, you can also click here, click on CES, and you'll see that it opens up this data viewer window. So clicking on the name of the object is basically like running the view command. Similarly, you can click the down arrow and that'll show you all of the different variables, and Shania will tell you tomorrow what INT, CHR, and those things mean. Yeah, I think like the summary and all that stuff is tomorrow, right?
Yeah, we're gonna do all that. Well, just as long as everybody was able to basically install R and like look at the data and then set up for tomorrow.
Cool. Any questions?
Super fine.
Oh, look at this mishmash. Ooh. What chump wrote this garbage?
Someone named John Santos.
Oh, there's the loser who wrote this code. Anyway, Dan, I'll let you close out.
So once again, sorry everyone, my voice is cutting out still. I'm still not at my full capacity. So thank you, John, for stepping in for a second. But yeah, that pretty much concludes day one of getting to know R. So we've run through what R actually is, how we work in R, best practices of working through R. And also importing our data. So if anyone has any trouble with importing the data or any questions from today, please let us know. Send me an email. You can send me a message or any of us an email. Yeah, so exactly. And yes, for the question in the chat, the recording will be saved. We're gonna record today and tomorrow, and then we'll create maybe like a Google Doc type of thing. We can save it with all of you. So yes, Shivani, it will be saved. So any lasting questions for today, online, in person? Yeah, so we will send all of the material. Lunch should be coming soon. It should be coming at 12. But nevertheless, if anyone has any questions, please send us an email or a message. And we look forward to seeing you tomorrow. So for those of you that are on Zoom, I can maybe keep it on for a couple more minutes if you want to send us a DM here. But if not, you're all good to go.